In my experiment, I used rubber bands to make a watermelon explode. The biggest principles that will be discussed are potential and kinetic energy, elasticity, and pressure. To perform this experiment, as you can see, we'll be putting rubber bands around a watermelon until it explodes. This will take 2 people to get the bands around it. When doing the experiment, I expected to see the watermelon explode and to get very messy in the process. I wasn't sure if the hard outer part of the watermelon would slowly crack and eventually crumble in on itself, or if it would be a literal explosion causing bits of watermelon to go flying. First, we should review a few definitions. Potential energy is stored energy that results from the position of an object. Objects that aren't in motion have this stored or potential energy. Kinetic energy is energy of motion. Like we talked about before, potential energy is when an object isn't in motion. When a force acts on that object, it will have motion. Potential energy then converts to kinetic energy. Elasticity is when a solid object can move back to its original shape and size. When a force acts on it, and that force is removed, the object will move back. Pressure is force on a given area. As force increases, pressure increases. Particles want to move from an area of high pressure to an area of low pressure because it doesn't require energy. Moving from an area of low pressure to high pressure, however, does require energy. This is because the force exerted on an object forces the particles to move away from the high pressure area. The increase in force causes an increase in pressure. The center of the watermelon, where the rubber bands are being applied, is a high pressure area. The particles move away from the center of the watermelon and towards the top and the bottom, which are low pressure areas. I could actually physically feel and hear this after enough rubber bands were on. In the beginning, if I tapped on the top of the watermelon, it sounded very hollow. Towards the end, it felt much harder and didn't sound hollow at all. What I was hearing was a change in pressure throughout the watermelon. I could see this when the watermelon would bulge out around the rubber bands like it was being squeezed. What I was seeing was also the increase in pressure and movement of particles. Eventually, the watermelon explodes. This is because the force of every single rubber band is acting on the watermelon. This causes pressure to build up super high away from the rubber bands. Eventually, the watermelon can't take the pressure anymore. Each rubber band that is wrapped around the watermelon slightly deforms the surface of the watermelon because there is a force being applied. The molecules on the surface are compressed and packed so tightly together. This tight packing results in an increase in potential energy. When the watermelon explodes from an increase in force and pressure, the molecules on the surface finally decompress, releasing all their stored energy in the form of kinetic energy. I think that the watermelon exploded suddenly rather than cracking because we started to move so quickly, giving the particles no room to move to even out. Eventually, the whole thing popped, and as a result, I will be washing watermelon bits out of my hair for an entire week. As you can see, after the watermelon finally exploded, the rubber bands around it flew off in a tight ball. Each rubber band, when you stretch it, has potential energy. When it goes back into place, it releases this potential energy in the form of kinetic energy. This sudden release is also elasticity acting. The force of the stretching is removed with the explosion, causing the rubber bands to spring back to their original shape and size. Of course, they all do this at the same moment, and we get a tightly wound rubber band ball.